Are we live? Well, if you're joining me, this is the very first monitor repair live stream I've ever done. I've been wanting to do it for a while. So let's see how that works. We're going to see if the audio is even working. Video, etc. We'll get right into it. What I have is some 6100 vector boards. That's what I'm starting on here. All right. Okay, audio, it sounds like garbage apparently. Let's see. I have to screw with it later. Just deal without audio. Yeah, it might be sitting here. I've never streamed on this particular PC, so I'm winging it. Okay. Has that amplified the audio at all? Testing, testing. I may have to be pretty close to the mic though. Has that amplified the audio at all? Testing, testing. Okay. I'm starting on that. Anyway, audio might be kind of garbagey. There's a lot of ambient noise, fans going and such, so we'll have to deal with it. Alright, I think I'm gonna post this here. Yeah. Probably a good idea. Whoops. Where are we? Where are we going? Here. Fans going and such, so. Post the thread. Okay. Alright. Phone's ringing. Okay. Welcome to the live stream. This is my first repair video I've ever done. We're going to see how it goes. See if you guys like it. Maybe I'll do more. I don't know. But no one's really ever seen. not many people have been here. See where the magic happens. See if we get a pan. Do a quick scan here. This is bench number 1. Yeah, all sorts of gear. And we got a bench number 2 over to the right. Oh, how's the focus? Focus is good. All right. Anyway, I won't do too much talking. I'm just gonna work myself into the repair here. Well, I normally don't take it in like this, but this fellow sent in only the deflection board and the HV cage. I usually have 6100s in all the time, so I have a full setup here I can bench it on. I did suggest that he send in the frame and the transistors that go with it, but we worked it out. We're just going to do the boards. Right off the bat, you can see rework has been done to this. Okay, where's my... Can you see the... Yeah, that works pretty good. See my microscope here. Is that coming in? There's been repair attempts on these both. It's very common that I get stuff that's gotten a world tour or previous repair attempts. It's got one of the many versions of the LV. Who knows if that's good? A lot of times they're not. Sometimes they are. I do see them coming dead though. All right, now you see that? Does that look good? Look at that. Hopefully that's viewable, but that's wiggly. Got a tear there. Pin posts are bad. Yeah, soldering isn't very good. These pin posts here, I don't know if you can make that out. They're round. These are stock, of course. The ones I use are square. I think they're better square because they get a better bite on the plug also. These are all going to go. They're going to get changed. Visually, I can see some burnt resistors here. The values are good. They're under here. You can't see them. The values are intolerance. One is drifted pretty bad. They took some damage here. This is probably open. Anyway, now I can put you to sleep because I'm going to start taking out stuff, tearing it out, replacing stuff. We'll go through the multimeter quick. I'm just going to look for some drops. Fuses are good. I'm just using a diode check for it because that's what I have it on. I'm going to check some key diodes. I'm replacing these anyway. Curious if they're shorted. Okay. This fuse here is supposed to be a slow blow. It's fast, so that's coming out. I'm going to change that in a minute. Start pulling things off now. Okay, nobody's watching. Good. The less viewers, the better. Remember that. That is the key to success. This is for the heater, part of the heater circuit. They drift. Value's pretty close, but sometimes they start to close a little bit. All right. I'm assuming the audio sounds pretty muddy. That's what happens when you got a lapel mic sitting on the desk next to fans and such. Anyway, we'll scan the board later with the microscope. I'm just pulling stuff here. You see that? Are you picking up my desolder here? The viewing window, the field of view is much bigger. And looking through this, the video capture part of it seems to only capture a portion of it, like a small postage stamp square of it. Normally I power the boards on first before I do any rework. This is if I see something off the bat where I know it's not going to work. Like reproducing the symptom that it was sent in for. Alright. It's quite a process from the board coming in, checking it in, to getting it back to you. Sometimes it's an all-day event. Some are easier than others. Some are hair pullers, some are normal, average. Regardless, every board gets a lot of attention. I don't just repair it, I want to make sure it's running right, the way it's supposed to. Yeah, this isn't uncommon for me to see new tears introduced to it from soldering. That just lifted off the pad. In previous rework. These headers are out. I'm just going to check the other fuses. 3 amp, 3 amp. 5 amp, that looks good. Oh, that is a 3 amp too. These are all 3 amp slow blow. On the deflection portion, the bottom one's actually R5. Looked like a 3 there for a second. You should know that. I'm just going to mark these good. This does have the input protection Wells Gardner mod. Very nice. Alright. This is the boring part. We're not really getting into the circuit here or exploring. We're not breaking it down, what the problem is. Because likely, I've seen the problem. And these are getting replaced anyway, a lot of these components. There's a lot of forward work here. So I'm prepping this board, making sure it all looks solid, and we'll power it up later with the provided HV cage. There's some small signals that are going to get changed. Oh yeah, these burnt resistors have to go. These are supposed to be 390, I believe. So let's look at that. Should be able to see that. Should be able to see that on the meter there. Whoa, is that open? Am I hitting the right one there? Nope. Flip the board. I don't think I can get in there. There it is. Yeah, got 380 there. I mean, it's I could probably keep them in there, but would that be? And no one would probably know, but I know. I would know. So I'm gonna change them. And the desolder gun is clogged. There we go. Open it up a little bit. Can you see this? Look at that. Where's the pad, right? It's gone. It's like pulling teeth. These components. Small signals are coming out. I see 2 factory lytics on this IPC board. Those will be changed. We're going to do all sorts of stuff to this board. Yes, indeed. Alright. Oh, I already took that resistor out. This 22 ohm is usually pretty darn close. Let's see where it's at. It's supposed to be 22 ohm. See that on the screen? Yeah. Does that look like 22 ohm to you? Not even close. $250K. What? Alright. Visually on top, I don't see anything else burnt except those 2. Well, now 3 resistors. Let's see, this says LV2000 Light R4. Jeff Hendricks, whoever that fellow is. 2018? Okay. Pretty modern, nice. Looks alright. Might still be working. Yeah, here we got the oscilloscope in the upper right corner, obviously. Maybe using that too. Okay. Well, behind me, I have a wall, literally, 15 feet wide by 8 feet high, just bins and bins and bins of components. That's just some of them. These are the ones that I grab most often, so I'm going to get some things out of here and start loading that thing back up. Alright, 7.5 ohm. PSA. 26 experience. 6 of those off the bat. Some diodes. 390 resistors. There. Look at that brand new bag. I took a couple out. 2 of those. Need those headers. 1, 2, 3, 4, 5. Woo. Get some music on. Should I put some on and annoy you guys? Yeah, this is gonna be a pretty dry repair here. Just kind of testing it out. Let me get used to it and comfortable. We'll make it more interesting. There's no cutting. This is all live. This is how it's done. What you see. No fast forwarding. Yeah. Yeah, the 6100 set, when you send an entire thing, it takes, it's an all-day job. There's a lot to it. Good amount of time logged into it. And that one I can't see. Come on. Get in there. There we go. I gotta put my visor on my eyes here. There we go. Just temporarily. This is like a 2.5x magnification. Causes eye strain. Not this guy though. That's my baby. Yeah. Any questions? Just throw them in the chat. I'll be watching. Don't be bashful. Don't be afraid. Okay. Got my last cup of coffee for the day. Quarter left. We like to cut it off at 3, but it's going on 4 now. Yeah. Yeah, these are kind of a pain to get in with that board on top, but we got them. Come on. All right. Now, these leads, you're supposed to cut them before you solder. I'll tell you why. Because if you solder them first and then cut, you're putting leverage. It's a nitpick. You can still do it. I still do sometimes. But you put leverage on there and then you can kind of pull on the trace. It's just all, you know, the physics of it, mechanics. What I'm saying is if you do this and then cut, it's not ideal. If you're going to do it, maybe do it to one lead if you want to hold it in place. Like there. See, now I'm kind of introducing leverage to the pad and the landing area. Not a big deal, but I'm just saying quality. So you're really supposed to cut them here like that first before you solder. Okay. There's certain situations where you want to cut the lead beforehand more than others, of course. But in practice, just always do it. Best practice. So that's what I'm going to do. Cutting the leads. And then I'm going to solder. They're fixed in place. They're not going to go anywhere. Now I can solder away. I like doing it under the scope, just to make sure I'm hitting everything right in the right place. I really need new glasses. This script is like 5 years old, so that might help too. But everything looks clean here. Everything looks 20/20 under the microscope, of course. Okay. See how clean that is? Alright. I'm going to continue to put components in here that I picked, and now the giant cement resistor walked away. Where'd it go? Where'd it go, people? Probably on the floor. Another universe. Always grab another one. Find it later. Oh yeah, and I need a 3 amp time fuse. Okay, 7.5. 3. Oh wait, yeah, it is. There it is. 3R. You know what? My mistake. The deflection transistors are supposed to be fast. Okay. Yes, you want those fast acting. To save them. Alright. There was one slow blow in there. Both need to be fast acting. Anyway. Alright. Oh, we need that 22 ohm. That's what that's what I need. Wow. Coffee's wearing on. 22 ohm. Enamels. I think I'm running low on those. Better order those. There they are. It's got a green enamel on it. Very nice. Yeah. We're almost done with the components. All the components that I believe are going to be needed. There shouldn't be anything else on this. And I have to scan the board again. Every solder point. I'm going to clean it up. Kidding. Don't know. Oops. What's going on there? Should be going in. Oh, I see. These are new headers. Just gonna trim them to size. Okay, 1, 2, 3, 4, 5. Yep. Look at that. An 11-pin header is now a 6-pin header. Very nice. See how clean that is? Look at that. See how nice? There you go. Three more. We have it. Got a 4-pin, 2 4-pin ones, and they're a tight fit. I'll tell you that. Get these in there. These pins are here. You can be able to see that. We're gonna put some flux on them too. I'm setting the keys. Got the key there. See? It's quiet in here. All I hear is fans. I don't really got music going or video, TV, all sorts of things. Okay, this one's for the yoke. Here, I'll show you that 22 ohm guy. There he is. It'll be 22 ohms probably for the rest of the chassis life. It's a nice quality resistor, so those are hard to burn out. All right. But they certainly will if you put the wrong pull on it. Okay. That's the last one. Wow. Every component changed gets marked. So when you get your repair back, you know. And I know what I changed. like so. Oops. Pretty cool, huh? The fuse. Did I mark those already? I think I did. Yeah. Running out of ink in there. There we go. Okay. Mark those. Diodes, resistors. That marks. Makes it nice. Makes it easier for everyone. I gotta solder these down. Hey, where's my flux at? Flux capacitor. Alright. Can you see that? I'm just gonna be liberal with it. Whatever. Look at that tear. That's gone. I'm just fluxing the pin posts. Not the stuff with the leads. Those are fine. There's enough flux in the solder actually. It's 2% on the core. We're good there. Alright. Right. How's that translating in the video? This microscope here. Looks good. Yeah, all that smoke you see likes to cling to the glass. So this glass is actually it's gonna get like a film on it that I'm gonna have to clean usually once a week or so, sometimes every 3 days. It depends. I'm cleaning the tip on some brass. Yeah, look at that damage there. There's no foil. We're gonna clean that up nice though. You'll see. Nothing like inhaling flux fumes. No, I'm not inhaling lead. That's a myth. I think the temperature to vaporize lead it's up there. It's pretty astronomical, so this iron will never do that. There's a tear there. I'm going to put some varnish over this lead just to make it look nice. Keep her nice and flush. This is just the component lead there. You can use thinner ones if you really want. Okay. I'm soldering here. See, like this lens is really foggy. I gotta clean it. But this is a 10x. You can see there, this is a factory solder joint. Not very good. Phone's ringing. Yeah, it's non-stop here. 24/7 doing stuff. I never stop moving. I need to hire someone to help with administrative stuff. I'll get there. I think that'd be good for me. It'd be good for you. You get faster turnaround, everything. Okay. You got everything soldered? No. Yeah. One more. So the lens I'm on now, it's maybe lost 20% of the clarity. It's got film on it, I can see. I might clean that here mid-repair. But it's still pretty sharp. Right? Yeah, it is. Okay, so I'm gonna grab some leads from a reel here. And we're gonna fix that damage. Oh, that's a solid joint. I'm not doing anything there. Okay. Go back over here. Where was it? There we go. Missing 3 spots there. That's previous repair damage. Not from me. Well, instead of using like insulated wire, I'm going to use these. It's clean, it's thin, it's flush. I'm going to paint over it too. So, yeah. It's like sewing. I work with my hands and my mind. Alright, get that guy on. Where did that thing... There's my little eyeglass screwdriver. How does this table eat things? Seriously. I just had it. Grab another one though. That's weird. Okay, back to it. See, that's pour right there. Flush. There we go. How's that? Not bad, huh? Two more. That's an easy one. Okay. Ah! All right. Okay. Should have everything in that I want in right now. Nope. Got 2 caps yet. What are these? 100 UF, 100 microfarad, 6.3 volt. No, 100 at 35. There's a little bodge job here too. I'll have to reroute that. I'm not sure why that was done like that. Must have been some hacking on the board below. Okay. Looks good. Okay. Alright. This board's ready for bench now, just about. A couple other things I want to look at. Okay. I'm going to look at every solder point catch up anything that needs to be. Do a scan. I'm going to clean that lens. I'm going to clean both of them quick. Yeah, there's a little bit of buildup, not too bad. If I don't have my spray though, I'm not going to run upstairs and get it. We'll do it later. That's not around here. Okay. Here we go. Okay. As I'm doing this too, I'm going to look for possible leads to clip that aren't going to fold over or hit anything. Sometimes they miss it even in the factory. Scan the whole board. I don't skip anything. Raster ones take a little bit longer, if you can imagine. Alright, so all these little holes are here because there was components that the fellow took out and put the LV board in. That's fine. I'm just going to make it look nice. Put some protection on them. I don't know. Whatever. Looks better that way, right? But if the LV's bad, we're going to put the stock stuff back in. My select components, proven good. Alright, now, look at all that. Look at that. All that garbage on there. See all this residue, material, rosin, flux, grime, dirt, all got to come off. There's an easier way to do it. This gets the big chunks away. And I'll show you. Okay, I'm just going to clean the board. How's that? There's some stuff that likes to stick around, but yeah, see, generally the rest of the board looks good. So I'll clean it up some more. And just overdo everything here. we do it right. I do it right. There is no we, it's just me. So, oh yeah, and then I wanted to show you how we're going to make these look a little more prettier. I like to put varnish over it. Two reasons. It wasn't exposed there in the first place, you know, conductor, and it prevents it from moving. Not that it really has a lot of wiggle room to move, but I like to keep it in place. And you kind of know too. That was a little too much in the varnish, but whatever. You know there was a lead jump. You can scrub it away too if you really want to. It's not completely permanent. Okay. All right. I'm gonna look at the board a little bit more before I do any power up. These check good. I did check those before. That we want. Okay. This is an original 6100 tube. Personal stack one. Now, okay. I don't even know if this guy works. I'm just going to test the deflection out without any high voltage. He didn't send in a neck board either, so none of this has been tested on. The only thing I looked at was the frame transistors, and they appear okay. There was some frayed wiring on a couple of them. There was opens on there, that's okay, but those should work for just the test here on the deflection. I want to make sure I nailed it. Place it in here. I'm going to plug the yoke in, and one set of the power transistors. I'm going to keep the two deflection ones off. I'm going to plug in this ground. I'm going to unplug the HVA. We're going to see what it's doing raw, alone. I shouldn't say raw, rebuilt. Where's that? There it is. All right. Get my meter on points. Positive B plus and negative. Let's start over here. B plus. I gotta drag my power brick out. Huh. Be right back. Okay, I'm not gonna hook any video signal to it yet. Just the power. See what's going on. And need a power cord. We're gonna get magic smoke? Or is this a one-shot repair? Repaired on the first attempt. Probably is. Okay. All right, 26 volts, 26 bolts. Looks good. V minus, or B minus. Okay, 26 looks good. We're going to put one set of deflections in and apply a signal from my homemade generator. My kit one. Alright. Where is the load? There it is. Hiding. Always hiding. Okay. I'm just going to listen for chatter and make sure nothing's dipping here. Yep, I hear it. B plus is holding. B minus is holding. I'll put the other set in. Should be really loud now. I don't think the mic's going to pick it up. I'll try putting it by there. If I got a long enough cord. Yep. That's good. Okay. Can you hear that? There we go. Can you hear that chatter? Sort of, maybe. Okay. Now, I don't have an image because I don't have high voltage, but this is the second part of his repair I'm going to work on. It may work. Should we try it? Yeah, let's try it. Let's see what happens. But it looks pretty. I see 2 burnt resistors. Doesn't mean they're bad. This one's pretty crusty. That HV potentiometer looks crusty. The soldering's horrible under here, so that's going to get all redone. I mean, does that look professional? Yeah, if it works, right? But I couldn't send it back like that. No thanks. So let's see what's wrong with this if it works. It might work with issues. This neck board is probably good. I didn't touch it yet, so. Oh yeah, and all these wires are, especially on the neck board, they're going to be kind of tied together so they don't flex as much because they like to fray because they're single core. It's pretty bad. They like to drop off. This wire's cobbled right here. Just hanging on by a thread. Alright. Power it up. See what happens. Let's see where that. Oh, I'm not even gonna touch that. Leave it how I came. Let's get our video B plus on measurement. Did I put anyone to sleep yet? Am I scaring you away? Okay, that's all hooked up. Double checking. Ground is good enough. We're going to change these spades here because one of them looks like it's going to break off. Okay. It's supposed to be at 181 on the video B+. Yeah, that's high voltage. What did it go to? Where's my ground here? 178. Huh. It's probably going to crawl up. It's probably going to go up to like 188 after you warm it up. But that's good enough. We have an image. I'm going to slowly turn. Oh, that's pretty scrambled. Ah. Okay. Let's see what we can see. I have to do some adjustments on the generator. Got spaghetti. Can you see that? Is it? Oh, I think I got this pinout changed. So I was screwing with something. Or a different setup. Let me verify here. It looks good. Is it on? Is it a wire? Oh, the high voltage just dropped. Imagine that. There's something else wrong with this HV cage. Well, I'm going to pull one of these off. See if it's X is messed up or the Y? Break out the oscilloscopes. B minus is good. B plus is good. We have a draw problem. So there's something likely still wrong with the deflection board. And this HV board, because it just tripped before. What? I don't know. I don't know yet. So we have to start looking around. Okay, I'm going to pull this. Let me see if I have a straight line. Full deflection left or right. Oh, up and down. It's out of. It's like off center or something. It's offset. Oh, there we go. That's center. So it looks like. Looks like north-south is good. Now I'm going to go east-west. Yeah. And it's missing a quarter. Or half the screen, I should say, not a quarter. That would do it, huh? Yeah. But why? Is it the deflection transistors yet? Because I don't know. They meter good. So maybe it's open in one of those wires. Otherwise it's the deflection board. Yeah, one's ice cold, the other's hot. Obviously. Oh, you got a pair down here. I got stuff all over. I'm just gonna use it for a second. Just to make sure that the frame ones are good. Yeah. Oh. What happened? I don't hear anything. Did I blow that one out? Or was it already? No, same thing. So it's not the deflection transistor, it's in the friggin' board. Okay, I can take the high voltage off. I don't need that. Should I keep going, guys? Keep going. Okay. Can't really get in there with a probe. Something like that. First thing I'm going to do is a visual. See if I missed anything. One of these could be bad. I think I tested them before. It could be an open somewhere. Probably what it is. I'm sure it's fine, but I'm just gonna double check for a tear. Could be something with the yoke circuit. Okay. Oh, this is hard to work with all these freaking cables. I'm getting an oscilloscope probe in there. It's just, yeah, it's not horrible, but a little encumbersome sometimes. Alright, yoke's on. Okay, so something with the X amp. What's going on, X? It could even be, this transistor. It could have could look good under the meter, but doesn't mean it is under a load. There might be an open resistor. Probably faster to just check that way, but we'll do it the scientific way. You don't know what's going on if you're blind. So let's see what we can see. All right. Here's our X input. Oh, this ground lead is, I'm fighting. I don't have much wiggle room. Let's get on down. Let's get on down. Well, let's find a better ground point here. Obviously. All right, the RDM signal hooked in here. What do we got? We got something. Hey, okay. So this is the part of the X pattern. Why are we only getting half? Huh? They say it's an easy repair, right? Yeah, easy fix. Just a fuse. Was working last night. Just needs a gasket. Anyway. There, how about them apples? Okay. Is it showing up? Oh, yeah. No, where is it dying? Why is it dying? Where does it go? Okay, I got two there. I need a schematic. Oh. Where are we? X world or Y? X world. Where's our input? Is it orange? There it is. All right. We got some signal processing here. Base collector emitter. Base, collector, emitter. Where's the yoke? Where's Mr. Yoke? Yokey yoke. Well, we know it's getting up to here, right? Two N 3762. Where are you? In 61. It's dying there. Here. Which one is that? 1-6? 1-6 is cold. This guy. R74. Fuse. Okay. Small signal. Q704. Q703. Diode. Yeah, this darn IPC board. I'm gonna get in my way. Why do you have to be there? Our 706 goes up to the IPC. Oh yeah, that's not on the schematic. I bet you it's in there. That looks kind of torn up now, actually. Wow. Alright, power it up, right? Oh, see it? Here's a frayed wire on the neck board. I was just talking about that. Jeez Louise. Wow. We would have lost our heater voltage. I'll get it there. That doesn't look too good. Yeah, something's getting, waveform's getting jacked up. Oops. Okay. Follow the yellow brick road. All right, it instantly. Where does it go? Get back on there. All right, so it instantly hits the IPC board, which I don't have a schematic for. So that's where I need to look first. I'm gonna have to wing it. Do we really need one? Probably not. Let's see. Is this torn up? Okay, resistor there. Flux capacitor. Let's get a visual there. Okay. This may be installed wrong. Something looks suspicious here. Let me grab an original. I think I might have one. Look at that, never installed. OEM. Okay, what did he do here? Well, that's peculiar. Someone added a resistor in one of the wire leads. Why? Why did you do that? That's right. Or mega ohm. Yeah, that might be a problem. Do I have some voltage on there? Well, anyway, this, yeah, it wasn't open, like obviously. The resistor is not burnt. There's nothing visually. That explains it. 3.3 ohm. And we use the correct watts here. We don't use stuff overrated. We use what it's called for. I love it when I see like tinfoil fuses or 10-watt resistors where a half watt was supposed to be. It's always fun. Well, we didn't get a deep dive into this, but whatever, you got an idea of some of the processes. It's probably going to work now. There's always a reason why something failed. Now, sometimes it's a defect in the component, sometimes it's because something else failed and it can snowball, chain react. I just want to take a look at a couple other things. Oh yeah. So there's a long ways to go yet. I gotta, well, on this whole set, but for this particular person, I just need to do the HV cage next. Clean that up, make sure it's running right. Make sure the high voltage isn't tripping, things like that. Alright, neck board's on. We're going to have magic smoke or magic draw on the screen. Okay. Where's the degaussing coil? Oh, I don't have one. Oh, that's falling. I think we're good. Let's get some high voltage back on. Should we look at that signal? Alright, we don't need to. Get a visual. Alright. Ta-da, right? I hope so. Oh, shoot. Do I not have heater? Did that wire fry? Oh, there's the video B+. I don't think the heater's working. What the hell? But I hear deflection. It sounds really strong. No, I don't have heater. Why did the heater get knocked out? I thought I just said that the wire was frayed. Yeah, no heater. Come on. Oh, forgot to solder it. I put it in there. That might help, huh? So remember, this is just one portion of the 6100, the deflection board. The neck board, the high voltage frame transistors, the wiring, loom, all works together. Okay. It's not spaghetti. But I think we still have an open. Is that picking it up in the mirror? You guys can't see it. Sorry. There's that box. Still got one cold. Finally open. It's deeper than I thought. What? R711. Guys, something's up with that. Let's take a look. Game signal off? Yeah. I have to pull the meter off. Oh, 11 ohms. I don't know. 10 ohm. Okay. That's right. It's got a burn mark on it though. It's got to get changed. It's supposed to be 10 ohm. It's a lot of them. Oh, that looks really cool. Ah, 7-Eleven. 10 ohm. Should have still functioned. This is taking way too long. You must be doing it the long way. Okay. We're on target here. It's going A-okay. I'm gonna take this guy out of circuit. This heat sunk transistor. Heat sinked. Oh, here's that guy I was telling you about. It reads 12 ohm. See how burnt that is? It's got some damage. Previous. I'm just gonna make sure there's not an open here. I wasn't reading a different part of the circuit. Getting fooled. Looks good. Okay. Oh, well, let's see if we got voltage to the transistor. We do, 26, negative 26, that looks good. Let's see if there's any action on them. Very carefully. Ah! Oh, jeez. What, just the D minus here? Yeah. That's normal. Okay. Oh. Wrong. All right. Pin 1, pin 2. Okay, space 1, 2, 3. Hold on, what colorway is that? Yellow, red. Yellow, red, green. No. Yes. Some audio change. Something changing on a flex. Alright, so it's on the other side of the yoke. That looks good there. Looks valid. Okay, look. Oh. Huh. That's 714. Oh yeah, wrong side. Okay, R714. Back to this. Oh, shoot. Easy. Good. Is that close? Well, anyway, this is taking way too long. I'm going to take a break. I will put the solution in the description later tonight when I get finished. See ya. That was fun. We'll do it again. Definitely. Most def. See ya.